Hi, and welcome to Chapter 13, Section 4, the sine function. So sine is like what we were talking about when you took geometry and you learned about SOHCAHTOA, right? Sine, opposite of hypotenuse, blah, 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 blah. So it's that first one. But now instead of looking at it in terms of a right triangle, we're going to look at the actual function, because sine is a function. Okay, remember, a function is defined as something that passes the vertical line test. And so technically, sine is a function because it does what you see on the paper. All right, so if you look at it, it goes up and down and up and down and up and down. And it's kind of like those limit problems that we did where, in fact, that probably was a sine function when we did those limit graph problems, where it went up and down and up and down in the same distance from top to bottom every single time it moved to the right. So that vertical distance isn't going to change. So when you go to the right and you go to the left, it's not going to get closer and closer and closer to a number. It's just going to keep going. It's called oscillating. So that means it goes up and down the same distance. Now, actually, oscillating just means it goes up and down and up and down. This happens to go up and down the same distance. Now, since you can see the function, if I wanted to find the value of sine at 270 degrees, then I would go to the graph and look at it. Right, so it's down here. And I know it's hard to see, but if you go all the way across, it ends up being -1. Sometimes it'll reach the maximum value of 1. And that happens between 0 and 360 one time, up here at 90. So that's where it would happen. What is the value of y equals sine theta for theta equal to 180? Well, if we look at 180, that's where it crosses the x-axis, which means y equals 0. So the answer is 0. And for what other values of theta on the interval shown does the graph of sine have the same value as for 180? So in other words, where else does it equal 0? Well, it equals 0 at 0 and 360. Degrees. Right, and so that's all it's really asking for right now. That's in degrees. So if you look at this page, well, now we're trying to find it in radians. And so we're going to be dealing with the same thing. The difference is that your interval is going to be split up by radians instead of degrees. That's all. So if you wanted to find sine of 2, well, we know by looking at this graph that sine of pi over 2 is at 1. So 2 would be just a little bit less than 1, right? So maybe 0.9. Sine of pi, well, let's find pi. Well, pi is right here, so that's 0. Sine of 3, well, that's just a little bit higher than 0, right? So about there. And because it's an approximation, I'm going to call that about 0.2. And right now, it wants us to check it using a calculator, all right? And you can just plug it into your calculator. When you do that, you're going to have to make sure you change it from degrees to radians, and I will show you how to do that when you come to class. Then we have sine of pi over 2. Well, that's right here. Let's pick a different color. Right here. So that's at 1. So that's 1. All right, so sometimes it's as simple as looking at a graph. Sometimes you're going to have to do a little bit more to figure it out, like we did in the last couple of sections. So, example 3. Find the period of a sine curve. Okay, that's what this topic is over. Now, this is the graph of y equals sine of 6 theta. The first question it's asking is how many cycles occur in this graph? So, a cycle is going from the starting point to the next starting point. So if I go up and around, it comes back one more time here. Okay, so that's one cycle. Then I would do it again. That's another cycle. Because it comes back to it goes all the way through. Okay, up, down, and back up. So that's another one. So that's 3. That's 4. That's 5, and that's 6. So on this, there are 6 cycles between 0 and 2 pi, because 2 pi is actually right here. That's 2 pi. So 6. And how is that number related to the coefficient of theta? Well, they're the same. So we can assume that the number of cycles from 0 to 2 pi is going to equal the number that's in front of theta. Okay? Find the period of y equals sine 6 theta. So that's asking you to find one of them. Okay, because to find one of them and then to find this distance. So we need to find the horizontal distance from here to there. That's one period. Now we know that the whole distance all the way across is 2 pi. And there are 6 of these in 2 pi. So to find it, we're going to take 2 pi and divide by 6, because that's how many cycles there are in 2 pi. There are 6 cycles in 2 pi. So to find the period, to find one cycle, you would just divide by 6. So we're really doing 2 pi over 6, which is the same as pi over 3, which means it takes a distance of pi over 3 to get from the starting point back to the original starting point as you go from left to right. Okay, that's how you find a period. And it's going to be very important as we proceed through this section. Now the next problem is asking us to find the amplitude. Now the amplitude is is half the distance between its maximum and minimum values. So if we look at this red function, also, the red function is y equals 3/4 sine theta. And the blue function is y equals 3 sine theta. And you'll see that there's a relationship here. Now, if the highest point on the red function is right here, and the lowest point is right here, then halfway from one to the other would just be the distance from the x-axis to the top. Now that doesn't always happen. Sometimes your sine functions are shifted up or down, in which case you'd really have to find that difference. But in the red's case, this is actually just 3/4. So the amplitude here is 3/4. And then the distance from top to bottom for the blue. So all the way from the top to the bottom. Well, all the way down would be 1, 2, 3, 4, 5, 6. And 6 divided by 2 is 3. So for the blue one, our A is 3. So we have 3 and 3/4. And how does the value of A affect the amplitude? It's the same. So it is A. And it actually is technically the absolute value of A, right, technically speaking. And I'll show you how that's affected in a second. Now, if I had a negative value of A, well, a negative, that would be on the outside, right? And outside's vertical, so it would reflect over the x-axis. So this would just be reflection over x-axis. All right, so now that we've gone through that and you've seen the relationship, this is a summary. Absolute value of A is the amplitude, so that's the distance from top to bottom times 2. Okay, because the amplitude, divided by 2. Because the amplitude is half the difference between its maximum and minimum values. B is going to be the number of cycles between 0 and 2 pi, and if it asks for the period, which it will, you take 2 pi and you divide by B. So whatever your B is. All right, because that's going to tell you how long it takes to get from the beginning point back to the beginning point after going through a cycle. So, sketch one cycle of a sine curve with amplitude 3 and period 4. Now notice, we just want to graph it. Okay, the period's 4, which means that it's going to take 4 to get from beginning to end, right? So if we start at 0, we will end at 4. Right? And because sine is the way it is, it's going to go up, down, and then back up, assuming that A is positive. Okay, and it doesn't say that it's not, so the amplitude is 3, that means the highest point is 3, and the lowest point is -3. Now, sine goes up, then back through the x-axis, down, and then back up, which means it needs to cross the x-axis right in between the two end values. Then we use the amplitude, and the amplitude is going to occur between 2 points here. So it's going to occur between 0 and 2, which is at 1. So it's going to reach its highest point at 1, 3, and its lowest point at 3, -3. Then we're going to draw the curve. It needs to be curvy. And I know I'm not good at drawing. All right, so there's one cycle of a sine curve with amplitude 3 and period 4. Part B says, write an equation with A is greater than 0 for the sine curve in part A. So now we need to write the equation that represents this. We know that the amplitude is 3, and because the equation is A sine B theta, y is going to equal 3 sine, and then some kind of b, right? Now we know b is the number of cycles in the interval from 0 to 2 pi. We also know that the period is 2 pi over b. So if the period is 2 pi over b, and our period is 4, we can set them equal to each other, which means that 2 pi equals 4b, and b equals 2 pi over 4, which is the same thing as pi over 2, which means that b is pi over 2. So when we go to put it in the equation, we write pi over 2 theta. There you go. That's the equation. Let's do a couple more of these. Graphing from a function. Sketch one cycle of y equals 5 over 3 sine of 3 theta. Now, we know that because the form is y equals the absolute A sine of b theta, we know that A is the amplitude, so the distance from top to bottom is going to be 5 over 3 times 2, right? So the highest point is going to be 5 over 3, and the lowest point is going to be -5 over 3. But before we can graph it, we need to find the period. We find the period by using the formula. The period is equal to 2 pi over b. Well, our b is 3, so it ends up being 2 pi over 3. So let's go ahead and graph 2 pi over 3. Now 2 pi over 3 is going to happen somewhere kind of like right here. Okay, because 2 pi over 3 is bigger than pi over 2, but less than pi. So if that's the end point, that's the beginning point, then it'll touch in between. We said that the highest point is 5 over 3, which is a little less than 2. So let's call it right there. And then negative of that, maybe somewhere right here. And we draw the curve. So don't judge my drawings. Make sure it's curvy. Bam. There's our graph. All right, one more. Find the period of the following sine curve, then write an equation for the curve. Now, the period, again, is the distance from start to end, which means that our period is 3. It says to find the period and then write an equation, so we are going to have to find the amplitude. So let's find the amplitude. That's the distance from basically here to here, right? And that's 5. Now, before we can really write the equation, if our period is 3, we're going to have to do the same thing we did in example 5. So we're going to have to set 3 equal to 2 pi over b and solve, which means that 3b equals 2 pi and b equals 2 pi over 3. And now we can write the equation. So y is going to equal 5 sine of 2 pi over 3 theta. And that's the answer. Now, you can always put that theta in the numerator if you'd like. We can write it as 5 sine of 2 pi theta over 3, and that means the same thing. And that's it. Have a great day.